Hello students, this is a video on the topic test for quant available on the Bodhee Prep app. The idea of these tests is often you wonder after you completed the basic concepts of a topic, whether the topic is ready for you in terms of the exam or not. So whenever you go through a topic, you're done with the concepts, you can take these tests topic wise to understand where you are. With every test, there is a video. This gives you the solution and a brief analysis of the level of difficulty of the test and maybe the amount of time that should have been spent on the test in the exam format. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description. Make sure you download the app and make the most of these uh, tests. This video is on the topic Maxima Minima. This is the fourth test on the topic that we are discussing. Overall, the test was easy to moderate, 6 to 7 questions. Net correct out of 10 in about 20 minutes would ensure that we end up getting a 95 plus percentile. If we look at the questions, first question says, which of the following is smaller? 51 raised to power 101 or 101 factorial? 101 is nothing but 1 into 2 into 3 into 4 and so on till 101. 51 raised to power 101 is 51 into 51 into 51. 101 times. Now if we rearrange this, we'll get 1 into 101, 2 into 100, 3 into 3 into 99. The first number, the last number. 4 into 98 and so on. Till the last we'll have 50 into 50. There are 102 numbers. The sum is 102. There are 101 numbers. So 50 into 52 and finally we'll have 51. This is the product that we'll get. So there will be 101, so 50 such products and then 51. We make 101 times. We make similar groups for 51 into 51. We have 51 101 times, so 50 times we can write 51 into 51, 51 into 51, 51 into 51, and so on, 51 into 51. This will account for 151. This will account for 151s and then a 51. Clearly, these two are equal. Now, if you look at each of the products, we compare them. The sum of numbers is same. 1 plus 101 is 102. 51 into 51 is 102. The product will be maximum when the numbers are same. So for each of this product, 51 into 51 will be greater than the corresponding product on the left-hand side. Therefore, since each of the products here are smaller, this number will be smaller. So out of the two, which is smaller, 101 factorial is the smaller number, becomes my answer. Again, basic concept of constant sum maximizing product should not take too much time to solve, but maybe moderate level of difficulty in terms of concept. The minimum value of ax square minus bx plus c is 0. Since it has a minimum value, we have to have a curve which is upward opening. There should be no maximum. A minimum will be there. Also, the minimum is 0. So if I look at the curve or the graph for this with respect to the x-axis, it will touch the x-axis and go back up. So the minimum value of this curve will be 0. What this also tells me is there will be exactly one root for the quadratic equation. Just find the necessary and sufficient conditions for ABC. Since there is a minimum, A has to be greater than 0. Also 0. That is positive. Also, since there is exactly one root, the graph of the function touches the x-axis only at one point to give a minimum value of 0. That means the discriminant has to be 0. So b square minus 4ac should be 0. Hence, the two conditions needed for our answer would be option C. I think this is a basic application of the rules of quadratic equation and therefore easy question within 1.5 minutes. Find the maximum value of 1 by x square minus 2x plus 4. If we want to maximize this thing, what we can do is we can minimize the denominator. Now, if we are minimizing the denominator, x square minus 2x plus 4, we see that this is x minus 2x plus 1 plus 3. So x minus 1 whole square plus 3. The minimum value this will have is 3. And therefore, the minimum value for this entire thing will be 1 by 3. and that will become my answer. Also, if I look at this quadratic, we'll see that the discriminant b square minus 4ac would be 4 minus minus 12. Therefore, this is always positive. If there was, or if this quadratic had real roots, then this quadratic would have taken a value of 0 at some point, and that would have been the minimum point, the maximum for the ratio. The answer would have been infinity. But since this term is always greater than 0, all I do is I look for the minimum for this quadratic, and that will give us the maximum for the overall fraction. So since the fraction is 1 upon x minus 1 square plus 3, when this part is 0, the denominator will be minimum, and therefore the ratio will be maximum. Option C. At best a moderate question, but again, solving time should not be very high, because the quadratic given is very simple. A square b cube into c is 108. What is the minimum value of a plus b plus c? A product is given. We have to find the minimum sum. The sum will be minimum and the values are same. Now, here we have a square, here we have a. So what we do is we split a into two parts, a by 2 plus a by 2. B cube, here b, therefore we split b into three parts, b by 3 plus b by 3 plus b by 3. C remains as it is. So if we find the minimum of this, we would by default find the minimum of this, because this is equal to a plus b plus c. So we need a by 2 and b by 3 here. So what we do is we divide a by 2 square, we divide b by 3 cube. The same will happen on the right hand side, 108 upon 2 square into 3 cube. So this becomes a by 2 into a by 2 into b by 3 into b by 3 into b by 3 into c will be equal to 108 upon 4 is 27. 27 upon 27 will become 1. And therefore this becomes equal to 1. Since the product of all the numbers is 1, all the numbers individually should be 1. And therefore the sum of these numbers will be nothing but 1 plus 1 plus 1 plus 1 plus 1, which will come out to 6. The minimum sum comes out to option D, 6. Again, because there are 3 terms out of, and we are splitting 2 terms, I'd say moderate. But since these questions are generic, and if we are doing this concept, we would have come across these questions, the attempt time should not be very high. Find the minimum and maximum value of x square minus 3x plus 4 upon x square plus 3x plus 4. Now, one way of doing this is you write x square minus 3x plus 4 upon x square plus 3x plus 4 is 8 is m. Rearrange this equation to get a quadratic, and there we check for the discriminant being greater than or equal to 0, so that x remains real. But here what I'm doing is, instead of following that method, I'm saying let write this as x square plus 3x plus 4. Since we have minus 3x in the denominator, so I'll write minus 6x. 3x minus 6x will give you minus 3x upon x square plus 3x plus 4. So I wrote the term in the denominator and the numerator, and then add or subtract whatever is needed to keep the numerator same. Dividing this, we'll get 1 minus 6x upon x square plus 3x plus 4. Divide by x. X square by x is x. 3x by x is 3. 4 by x is 4 by x is 4 by x. Now, if I look at x plus 4 by x, upon 2, am is greater than or equal to gm under root of x into 4 by x. So x plus 4 by x is greater than or equal to x and x cancel, root of 4, 2 into 2, 4. Minimum value for this is 4. When we put this as minimum, this ratio will be maximum. And since we are subtracting the maximum value from 1, we'll get the minimum value. So if I put the maximum value for x plus 4x, I'll get 1 minus 6 upon 4 plus 3, which will be 1 minus 6 by 7, which is 1 by 7. This becomes the minimum value. Maximizing the denominator, minimizing the denominator will maximize the ratio. Since the ratio is being subtracted, the overall value will be minimum. Next, the flip side of this is when we put x plus 4 by x as minus 4. In that case, you'll get 1 minus 6 upon minus 4 plus 3. This will be 1 minus 6 minus 1 or 1 plus 6. This will become the maximum value, that is 7. So we write the minimum value for the positive, the maximum value for the negative, and from there we'll get the minimum and the maximum values for the overall expression, which is 1 by 7, and 7 becomes the answer. I'd say moderate to difficult question because there will be calculation involved, about 2.5 to 3 minutes to solve. The other way of going about the question, as I was mentioning earlier, will be write x square minus 3x plus 4 upon x square plus 3x plus 4 is equal to m. Cross multiply x square minus 3x plus 4 plus m x square plus 3mx plus 4m. So x square on one side becomes 1 minus m. X on one side becomes minus x into 3. This becomes minus 3m. Plus 4 minus 4m. This is equal to 0. Now for x real, discriminant has to be greater than or equal to 0, which means 3 minus 3m whole square b square minus 4 a c. They should be greater than or equal to 0. 3 minus 3m square gives me 9 plus 9m square minus 18m. 9 to 18. This will become, we can take the 4 common from here. We'll have minus 16 into 1 minus m whole square. 1 minus m into 1 minus m. Which will be 9 plus 9m square minus 18m. 1 minus m square will be 1 plus m square minus 2m multiplied by 16. So minus 16 minus 16m square plus 32m. Minus 16 minus 16m square plus 32m is greater than or equal to 0. Minus 9 and 16 minus 7m square uh, 32 and 18. There is one little problem that happened. This will be plus 3 minus 3x minus 3mx. Taking minus common will be 3 plus 3m, not minus. Therefore, this will be a plus, this will be a plus, this will be a plus. And therefore, a plus 18m plus 32m will give us plus 50m. And then minus 69 will give us minus 7. Multiply by minus 1, 7m square minus 50m plus 7 is less than or equal to 0. Multiplying by minus inverts the sign. 7m square minus 49m minus m plus 7 is less than or equal to 0. This becomes 7m into m minus 7 minus 1 into m minus 7 is less than or equal to 0, or 7m minus 1 into m minus 7 is less than or equal to 0. So critical points become m minus 7, 0, 7, 7, m minus 1, 0, 1 by 7. Positive, negative, positive, and therefore the value for m will lie between 1 by 7 and 7. Hence, smallest value 1 by 7, largest value 7 becomes the answer. PQ are positive variables. What is the least value of? Let us just multiply these terms and see where it goes. P into 1 by P. P into 1 by P will be 1. P into 1 by Q will be P by Q. P into 1 by R will be P by R. Plus Q into 1 by P will be Q by P. Q into 1 by Q will be 1. Q into 1 by R will be Q by R. R into 1 by P will be R by P. R into 1 by Q will be R by Q. R into R will be 1. rearranging them 1, 1 and 1, which is 3, plus P by Q plus Q by P. P by R plus R by P. Q by R plus R by Q. We had 9 terms, 1, 2, 3, 4, 5, 6, 7, 8, 9. All the 9 terms have been accounted for. Now, since these two are reciprocals of each other, we can say that arithmetic mean P plus P by Q plus Q by P upon 2 will be greater than equal to root of P by Q into Q by P. Q and P both get cancelled. And therefore, P by Q plus Q by P has to be greater than equal to 2. So the minimum value that this will take is 2. So we can say this sum will be greater than equal to 3 plus 2. Similarly, the minimum value this will take is 2. Similarly, the minimum value that this will take is 2. And therefore, the sum has to be greater than equal to 3 plus 2 plus 2 plus 2, which is 9. What is the least value? Least value will be when it is equal. And the least value will be 9 becomes my answer. I'd say maybe a moderate question because 3 variables are there. Some amount of arrangement needs to be done, but not more than 2 minutes to solve in any case. For what values of x does y assume the maximum value? Y is defined as minimum of 3 functions, 4 minus x, 0 and 3x minus 1. Let us simply draw the curves. If I say y is equal to 4 minus x, y is equal to 4 minus x, when x is 0, y will be 4. Y is 0, x will be 4. And therefore, we get a line like this passing through 4, 0, 4, 4, comma 0. Y is equal to 0 is this line. 3x minus 1. Y is equal to 3x minus 1. When x is 0, y will be minus 1. When y is 0, x will be 1 by 3. Positive x, negative y. Will pass somewhere from here. This will be 1 by 3. This point here will be minus 1. We are looking at y is the minimum of these 3 functions. So for values of x, if you look at the minimum value of y amongst the 3 lines, it is minimum here till this point. This is the minimum line. Then out of these 3 lines, this is the lowest line. And then again, after 4, this is the lowest line. So if you look at the value of y, it will be the blue line, which will be the curve for y. We can clearly see the maximum value that it reaches is this straight when the value of y is 0. And this happens for all values between 1 by 3 and 4, both included. So from the graph, we can simply say for what value of x does y take the maximum value? From 1 by 3 to 4, y has a value of 0, and that is the maximum value that this function will take. Again, this is a standard sort of a question. There are 3 functions, so some basic calculation might be required. Or if nothing works, we can always put the value and check. So about at max 2 minutes to solve. For what value of x would y assume the maximum value where y is minimum of the 3 functions? Again, we do the same process. We'll draw out the 3 curves. Y is equal to x plus 3. x0, y is 3. y0, x is minus 3. Plus 3, so passing somewhere here. This is plus 3. This is minus 3. Y is equal to x plus 3. Y is equal to 2x minus 1. X0, y is minus 1. Minus 1. Y0, x is 1 by 2. 0 is equal to 2x minus 1, x is 1 by 2. Somewhere here, the slope will be 2 steeper. Something like this. 1 by 2 minus 1. Y is equal to 2 minus x. Y x0, y2. Y0, x2. 2 and 2. Passes somewhere here. So if we look at it, the value, we're looking at the minimum of the three values. Minimum of the three values. Always this line will be less than this line. For example, if you put x is equal to 0, this is 3, this is 2, this is minus 1. X is equal to minus 5, this is 2, this will be minus 11. Out of these three lines, you see, this is always the minimum till this point. After this point, this line becomes a minimum value. So the blue line will be the curve for y, not this part. And the maximum value that it takes is somewhere here, which is the intersection point of the lines 2x minus 1 and 2 minus x. So 2x minus 1 is equal to 2 minus x, which means 3x is equal to 3 or x is equal to 1. So the maximum value of y happens when x is equal to 1. This probably would be a moderate to slightly difficult question because we'll have to find out intersection points and there are three lines. So that is the only challenge, about 2 to 2.5 minutes to solve. For what value x would the expression minimum of mod of x minus half, and the second is half minus mod of x minus half. Assume the minimum maximum value. Maximum value. Okay. Now, since we have x minus half in the mod, we can say there are two cases. X minus half is less than 0 or x is less than half. In this case, both these will be negative. We will have minus x plus 1 by 2 minus 1 by 2 comma 1 by 2 plus x minus 1 by 2. Therefore, the net that we'll get is negative. This will also be plus. This will be minus. Minus x comma x. This is when x is less than half. If we draw the curve for this line, less than half, we are choosing the minimum value out of minus x and x. So at x is equal to 1 by 2, we'll have minus half and half. The minimum value will be minus half. When x is 1 by 2, we'll have minus half as the value. When x is 0, the value will be 0. When x is, say, minus 1, the minimum value will be 1 and minus 1. And then it will go negative from here. Something like this, probably. For 1 by 3, it will be minus 1. So this will be the net graph that we'll get for x is less than half. When x minus half is greater than equal to 0 or x is greater than 1 by 2, in this case what happens is both will be positive. So we'll get x minus half half minus x plus half. This will be x minus 1 comma 1 minus x. So, we are looking at the minimum of these two values. When we put x as half, this will return minus 1 by 2. This will return 1 by 2. So we start from here. When x is 1, this will be 0, this will be 0. Somewhere here, we look at the minimum value. When x is 2, this will be 1, this will be minus 1. Something like this is what we'll end up getting. And therefore, as we can see, the maximum happens at these 2 points, which are 0 and 1. While plotting the graph, we can spot that. Or what we can do is we can simply put the values here and check. Put the value of x as half, see what the value you're getting. Put the value of as half, see what the value you're getting. Put the value of 0 and 1, you'll see that the maximum value happens at 0 or 1. Again, this one probably it says a moderate to difficult question, 2 to 2.5 minutes to solve. Find the least value of max of x minus 3, mod of x minus 3. Mod of x minus 3 will be something like this, 3. 5 minus mod of x. Mod of x is here, minus mod of x is here, we add 5. So it gets shifted by 5 points. This will be 3. When x is 0, 5. At minus 5 and 5. This will be the graph for 5 minus mod of x. We are looking at the maximum of these two values. So if we plot the overall graph, it will look something like this. In blue color. This is the maximum, then this is the maximum. Here, this is the maximum. And then this is the maximum. The blue color will be the line or the graph for the function, maximum function that is given. We have to find the least value of this. The least value clearly happens at this point. In this point, x is greater than 3, less than 5. And therefore, this will be positive. So x minus 3, this will be negative, is equal to 5 plus x. X is greater than 0. Both are positive. Both are positive. Since x is greater than 3, so x minus 3 will be positive. X is greater than 3, therefore mod of x will also be positive. So 5 minus x, which gives us 2x is equal to 8, x is equal to 4. At x is equal to 4, we will have the least value of the maximum function. What will be the value? Put the value 4 here. 4 minus 3 mod is 1, 5 minus 4 is also 1, and therefore the minimum value of the function will be 1, becomes the answer. Therefore, if I look at this question, I'd say easy to moderate, 1.5 to 2 minutes to solve. If you look at the overall test, we are looking at about 7 questions in 20 minutes. For me, my 7 questions will be 2, 3, 4, 6, 7, 8, 10. Which are these? I'm not counting this as the easier question. Might not strike every time. This, I think, was a straightforward quadratic question, so definitely attempting. This also, because the discriminant was greater than 0, we just had to find the minimum of the quadratic. Definitely attempting. Have done questions like this earlier, so definitely attempting. Again, if you've done this and you think comfortable with the calculation of discriminant and quadratic, go ahead. I am not counting this as one of the easy questions. Again, this was a straightforward question. P by q plus q by p minimum value. Should have done this as well. Draw the graph. The question is simple. Similarly here, draw the graph. Question was simple. Therefore, since they've done questions like this earlier, would have done it. Since I'm looking at the easy questions, I would not count this question because drawing x minus half mod minus half and half minus mod of x minus half, drawing the graph is a little difficult. And therefore, there are chances of mistake happening. So not counting this as an easy question. This one could have been done. The graph was pretty straightforward. And therefore, my 7 questions will be 2, 3, 4, 6, 7, 8, and 10.